When a positive integer n is fed into a machine, the output is a number calculated according to the rule. We put n inside the machine. If n is even, then we divide by 2. If n is odd, then 3 times n plus 1. We multiply by 3, add 1. For example, if we put n is equal to 7, since 7 is odd number, we get 3 times 7 plus 1, which is 22. Then if the output is repeatedly inserted into the machine 5 more times, the final output is 26. We see the outputs. When the same 6-step process is applied to a different starting value n, the final output is 1. What is the sum of all such integers? To solve this problem, we have to start with the final output and reverse this process 6 times and get our initial input. Okay, we start with the final output. We have to reverse this process 6 times. And how we can reverse it? Either if n is even, we are dividing by 2, n is odd, we multiply by 3 and then add 1. So to reverse this process, either we multiply by 2, to go this way, either we have to times by 2, or we multiply by 3 and then add 1. We should subtract 1 first and then divide by 3. These are the way to reverse the process. And each time we have to get an integer value, positive integer value. Okay, let's start with the first reversing. So it has to be 1 times 2 is 2. We can have 1 minus 1 is 0, 0 divided by 3 is 0, 0 is not a positive integer. So the first reversing, we have to get 2. And now the second time, if we reverse it, we have just times by 2 is the default. That's easier value to get. We can start with 4. If we do 2 minus 1, which is 1, and then 1/3, that's not an integer. We can do this reversing. Now, third time, let's reverse it. In here, we can put in 2 different values. 2 times 4 is 8, or it could be 8, or 4 minus 1 is 3. 3 divided by 3 is 1. We can have 1 in the step. 1, 2, 3 times we reverse it. And the fourth reversing now, we can have 16. If we have 8, 8 minus 1 is 7. 7 divided by 3 is not an integer. So the only option, if we have 8, in the fourth reversing, we have 16. If we have 1, we can have 2. The fourth reversing. Now, if we have 16, we can multiply by 2, or second, third, fourth, and this is the 5th time we are reversing. We can have 32. Or 16 minus 1 is 15. 15 divided by 3 is 5. So we can have, let's put this one is a little bit down here. Or in this reversing process, we can have 5. 5 times 3 is 15 plus 1 is 16. And have 5. If we had 2 here, we have to multiply by 2. The only value for input is here 4. And finally, this is the last time we are reversing. 32, we can multiply by 2, which is 64. 64 could be the n value. Or 64 minus 1 is 31. 31 divided by 3, that's not an integer. If we have 5, 5 times 2 is 10. We can start the number 10. 5 minus 1 is 4. 4/3 is not an integer. If we have 4, we have 2 different values. Either we have 8 is the starting number. 2 times 4 is 8. Okay, let's put it like that, 8. Or we can have 4 minus 1 is 3. 3 divided by 3 is 1. We can start the process, the integer 1. So these are the possible input values for n. 64 plus 10 is 74. Plus 8 is 82. Plus 1 is 83. So the answer is the sum of all such integers is 83, option E.